Okay. So today, again, we're going to do 7.5, which is essentially called linear programming. We're doing maxes and mins today. So we're going to find maximums and minimums, and we're going to kind of find it a couple different ways. I believe you have one problem that looks just like this for your homework tonight. So that's why we're going to do 3 problems today to kind of go through all of this stuff so that we can get the hang of it. There's a couple different pieces going on here. So these lines right here are for our equations. You don't even have to label it. You can just kind of look and see this is where we're going to put equations. I've got my graph right here. And then I essentially have this table that kind of helps me keep everything in order. I found that I like doing the table first, and then from the table, I do my equations, and then from my equations, then I build my graph. From this table, though, it's really easy to jump into a matrix. And since we're in the matrix unit, we are going to jump into a matrix to prove our answer at the end, okay? When you do this on a quiz or a test, you can do it in whatever order makes you happy, but I will tell you all of these pieces will be there. So even if you think that you can solve it by just going straight over to the matrix, I'm still going to want your equations. I'm still going to want your graph too. Okay, so that's why we're going to practice all of those things. All right, again, like I said, this is linear programming. That's just a fancy word for what we are doing. Because these equations are all going to be lines, and we're going to find, bless you, places where they intersect. And that being said, we care most about maxes and mins. We're going to have an equation in every single one of these that we plug our answers, our X, Y's into, and decide whether it's a maximum or a minimum and which one we want and why we want that. So that's just something to kind of keep in mind as we go through this. Okay. So this first problem, I'm going to be honest, I'm kind of tired. I don't really want to read this out loud. So just kind of read this silently to ourselves. We're all in high school. We can read a little paragraph to ourselves. So read it out, read it to yourself and think about like what's important here. As you finish reading that, jump down to the table below and see that I have it kind of labeled. So we're going to use the labeling here and put the numbers from the statement above into this table that we will eventually convert into equations. Okay. The first line that I've got is NIT for nitrogen, right? Yes, nitrogen. So that's the element that we care about. So there's a column that says A, a column that says B, and then a column that says total. So I'm going to break it apart. I'm going to say, okay, how much nitrogen is in brand A's bag of fertilizer? How much do we have in the first bag? Brand A has 4 units of nitrogen, right? So I'm going to go put 4 next to A. Now we're going to go do B. So I'm going to go to brand B and see that it has 1 unit of each nutrient. So that means it has 1 of nitrogen. And then total comes from earlier in the problem. It tells us how much total we need of the nitrogen. It says we need at least 180 units of nitrogen. So I'm going to go put 180 in my total. In addition to that, though, I am also going to put, this isn't necessarily needed in my table, but it's going to help me when I do my equations later. It says we need at least that. So I'm going to do a greater than or equal to sign to just remind myself when I do my graph later, I'm going to have to do a greater than or equal to. Okay. Now I'm going to go down and I'm going to do my phosphorus next. So I'm going to do the exact same thing. And in brand A, I have 1 unit of phosphorus. And in brand B, it said earlier that I've got 1 unit of each element. So I'm going to put a 1 for brand B as well. Going back to the beginning, it tells us that in the same sentence, it tells us we need at least 180 units of nitrogen. We also need 90 units of phosphorus. So we're going to say at least I'm going to use that greater than or equal to, again, 90 of phosphorus. Now, last is cost. And when I do cost, I'm going to think about how much each of those are cost me money, I guess. I wanted to use it earlier, honestly, and I like the table because it keeps everything in order. I would have loved to use $10 earlier, but now is the time that I'm going to use it. So brand A costs $10 and brand B costs $5. So when I come down to my table, under cost in A, I'm going to write 10, and under cost in B, I'm going to write 5. I actually don't have any total here because I actually want to know what that is. I don't know what it is currently. I'm going to figure it out based on what we do. Because we're maximizing and minimizing, I want to leave that blank. And let's think about it for cost. Are we looking for a maximum cost or a minimum cost? Minimum, right? We want to spend the least amount of money. And the problem also says we want to minimize the cost. So when we go put that in, we're going to go to the minimum. Okay. The reason we did this table is because now these make really nice equations for us. So I am still in my purple pen, which is that cost. I'm trying to be color coordinating on purpose. My cost is 10 and 5. So when I do that, I'm going to treat this first column as things that go with X and the second column as coefficients that go with Y. So I'll start this by saying 10X plus 5Y. We don't know what it equals. I'm just going to write equals cost so that I remember that's kind of what we're doing. Our two options really are cost or profit, and the problem will tell us which it is. In this case, we've got cost. I'm going to do the same thing with the nitrogen and the phosphorus equations too. So I'm going to do my nitrogen equation is 4x plus 1y is greater than or equal to 180. And that was my N, my nitrogen equation. I just put a little N next to it so I know where that came from. Now I'm going to do the phosphorus one, my P equation, which is x plus y is greater than or equal to 90. Now, if you notice, I left a bunch of lines blank. There are two more that we need to fill in, but they will always, always, always be in these equations. The first one is going to be x is greater than or equal to 0, and y is greater than or equal to 0. X and y represent how many bags of brand A and brand B we're going to get. You can't have negative bags, so it's always going to be bigger than 0 for my X and bigger than 0 for my Y. Okay, like I said, next we're going to take these equations, we're going to graph them, and then last we're going to be able to check our work by doing a matrix, okay? In the future, we can use matrix earlier, but for this one, I wanted to do this graphing wise. I think it's pretty easy on these two to just put it in slope-intercept form. So I'm just going to move my x's to the other side. So this equation becomes y is greater than or equal to negative 4x plus 180. And my phosphorus equation becomes y is greater than or equal to negative x plus 90. When I go graph these, I'm going to kind of make a scale with my graph because I don't have enough to go all the way up to 180, counting each box as a unit. We'll count each box as 10, okay? So we'll go 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm in blue, so I'm going to stop at 90 because that's my first y-intercept. And I'm going to label it as the point 0, 90. That's its xy coordinates on this coordinate plane. Since it's in slope-intercept form, my slope is -1. So I'm going to go down 1 over 1, down 1 over 1 the whole time until I get to the other side. Down 1 over 1, down 1 over 1. And that's at 1, 20, 30, 40, 50, 60, 70, 80, 90 again. So that's at the point 90, 0. Everyone hanging in with that? All right, let's go do the next one. Let's do our red graph, which maybe I should have done first. We're going to go all the way up to 180, and then our slope is going to be -4. So we're going to go down 4 and then over 1. 90, 100, 110, 120, 130, 140, 150, 160, 170, 180. And now I'm going to go down 1, 2, 3, 4 over 1. Now I end though with 1, 2. I can only go over 1/2. So I'm at the point 10, 20, 30, 40, 45, 0. because I'm halfway between 40 and 50, so I'm at 45. All right, I do not need to graph my max and min because we don't have what it equals. We got too many variables there. You can physically graph the X and the Y are greater than 0, but the fact that we're only in the first quadrant is enough information for me. That being said, though, I do need to shade. So I'm going to shade above both lines. That's why I have a solid line. Now I need to shade above it. So I'm going to get my little highlighters and I'm going to highlight. Oop, I want a much bigger one than that. Okay, so I've got my blue one. I'm going to do my red one on top of that. All right, and when you do the shading on pencil, sometimes it like feels like a little crazy. You're like, I don't really know what's the different part. That's why I like to shade it with my colors because I feel like it's a little bit more obvious. Okay, the problem that lies is that you need the points that first are on the X, or sorry, that both lie in the blue and the red, but I like to do the exact points that we currently have right here. So I'm gonna take, if we go to the middle point, I feel like that one's very obvious. It's very obvious that we need this point right here. That point's at the point 10, 20, 30, 10, 20, 30, 40, 50, 60. So that point's at 30, 60. Now we also need, there are two other points that I see that are on both the blue and the red. If you look down at the bottom, 45.0 is just in the red, but if you scoot over to 90.0, that's in the blue and the red. It touches both. So we need to count that point. We also need to look at the point up on the y-axis. 0.90 is in just blue, but if I go up to a 0 and 110 or 180, that's in both red and blue. So I got to count both of those. Okay. What we do now is we take these points, all the points that we find, this time we had 3, and we need to plug them into our cost equation and see which one minimizes the cost the most. So if I plug in 0, 180, what's that going to be costing? If I plug in 3060, what does that cost? Okay, so we're going to practice that now. So we're going to go do, I think I had 0, 180, 3060, and 90.0. Okay, yeah. So I'm going to take my purple equation. I'm going to plug all of them in for that. 10 times 0 plus 5 times 180. You don't necessarily need to show me the work like I'm showing you right now, but sometimes I find it helpful to keep track of everything. That first one is going to be 900. 10 times 30 plus 5 times 60. That's going to be 600. All right. I got 900, 600, 900. So the 600 is going to win because it's the least amount. So we're going to highlight that. All right, technically that's enough to have answered my question. The question on the problem says, how many bags of each brand should be purchased to minimize the cost? So I would go and I'd say, oh, we need 30 bags of brand A and 60 bags of brand B. However, guys, we're in the matrix unit, right? So you're probably like, what are we even doing with this? We can take our table from before and we can do a matrix of these 3 columns, 2 rows. This is an augmented matrix, and we can solve that and see what we get out of it. Okay, so let's do that. I'm gonna write this as a matrix. It becomes 4, 1, 180, 1, 190. Just like I mentioned on the homework, if nobody clarifies, if I don't give you any directions on what to do, let's do RREF. Let's plug in that augmented matrix. Let's plug in RREF and see if we get what we want to get. Let's see if we get 30 and 60. Okay. Let me get my calculator up. If anything, this is nice practice on just using our calculator. Second matrix, I'm going to edit A, 4, 1, 180, 1, 190. It worked. Double check, make sure you get what I got. Yeah. You doing okay with that? Now, the reason we still graph is because sometimes we may get this number and it may not actually be the minimum or the maximum or whatever. So we got to just be careful. And that's why we check all of our answers. Okay. Let's go down to the next one. This one is a little funky and we are not going to be able to check the second one with our matrix, but the third one we will be. So that's why I reviewed that. Okay. Let's read this one again by ourselves and then see if you can fill in the table. Also, is it very hot in here? Or is it just me? Very hot. It's like sleeping hot in here. All right, so as we read this, let's see if we can fill in the table at the bottom with this stuff. Okay, so it has low, medium, high, and then it has factories A and B, and then it has total. So low grade, it looks like in factory A, it's 8 tons of low grade. And in factory B, it's 2 tons of low grade. And we need a total of 24 tons of low grade. So I'm going to do 8, 2, and 24. This is another one that's an at least, so I'm going to do a greater than or equal to. Everybody okay with that so far? All right, let's go do our medium grade. Our medium grade says in the factory A, it's 1 ton of medium grade, and factory B is also 1 ton. And we only need a total of 6 tons in general. 1, 1, 6. All right, and then high in factory A, it's 2 tons of high, and factory B, it's 8 tons of high, and we need a total of 30 tons of high. It's almost backwards of what we had for the low one. And then the very last equation we've got is our total cost. The cost, again, it will not have a total, so I can black that one out. And if I go back up to my work, it says factory A is $2,000 per day and factory B is $4,000 per day. All right, now that I've got this table, let's write those as the equations above. I'll do cost first. remember with cost, we like to minimize, so I'm gonna do 2,000 X plus 4,000 Y equals cost. Then I'll do my high, I've got 2X plus 8Y is greater than or equal to 30. Am I moving too fast, or is everybody okay? Medium is gonna be X plus Y is greater than or equal to 6. And then low is 8X plus 2Y is greater than or equal to 24. And then we always have to do our X and Y. X is greater than or equal to 0, Y is greater than or equal to 0. Always got to do those two. Okay. All right, I will tell you that the matrix does not work in this equation in this way because it's a 3 by 3. It's not going to, if you put it in, you get all the way down to identity matrix, which we did in my last class. And I was like, well, that wasn't very helpful. So when it looks like this, you can't do a matrix. But we're going to go graph our blue and our purple and our pink line and see where they cross and where they intersect. And then we'll plug points in just like we did last time. You're welcome to do slope intercept again. I do want to remind you that you can also graph using just the intercepts. So if you want to graph intercept wise, which I think is easier in this case, when we graph using our intercepts back in algebra 1, we did that by plugging 0 in for y. So basically I acted like there was no y term. And I was like, okay, if 0 is in for y, what does x equal? Well, 8x is greater than or equal to 24. X is going to be 3. Do you guys kind of remember doing that? I remember helping Algebra 1 kids with it. I know I didn't teach it to you, but we also can do it for the y-intercept. So I can plug a 0 in for my x, essentially pretend that x isn't there. 2y is greater than or equal to 24. That means y is equal to 12. We're going to do that with both the other two equations. I'm not going to walk you through that. You guys can, I think, figure it out yourselves. And then I'm going to go graph the intercepts and connect the dots. .75. My only suggestion is make sure that you get your y's on the y-axis and the x's on the x-axis. I messed that up last hour. 1, 2, and I'm going to go by ones this time. I don't think I need to go by tens. 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15. 15, 0. Um, 6 and 6. And 12. All right, once you graph them, then we want to do our little shading. We're going to shade everything above it. The shading helps me on this when I've got 3 lines because there's going to be several different places where all 3 of the colors converge, where purple and pink and blue are all together. So I'm going to do my shading right now. Okay. Once you have that, I'm going to kind of zoom in on this part where really most of the action is happening. And we want to find out where we've got points where there's pink and purple and blue. Okay. So I like looking at the edges first because I think those are the easiest to see. The two farthest away edge points are the ones that work. So 0, 12 works and 15, 0 works. Because there's both blue and purple and pink. This in between might be a little bit funky. I'm going to argue where the pink and the purple intersect is not a point. This guy is not a point, but where the blue and the purple touch, that's within the pink boundary. So that counts as a point. And where the blue and the, bless you, where the blue and the pink touch, that is also a point. So the first one is at 1, 2, 1, 2, 3, 4, 2, 4. And the second one's at 1, 2, 3, 1, 2, 3. Once we find all of these points that are possible, we're going to go plug them in and see which one of them minimizes, which one of them gives us the smallest amount per cost. So you need to plug in 0, 12, 15, 0, 3, 3, 2, 4. All right, it's kind of a close one, but I got that the 3 and the 4, 3 and 3 were my best options here. So I'm going to write on the line below. I'm going to say that we should have, the question was, how many days should each factory operate to fill the order at minimum cost? I would say each factory should be open for 3 days each in order to minimize the cost. Because we got 3, 3. So both factories should be open 3 days each. Okay. All right. Let's look at the last one. If you notice, the last one does not have the little boxes filled in. So why don't you take a minute, read the problem, and then we'll try and fill in the labels together, and then I'll let you kind of go from there. We'll fill in the labels together. You guys ready to talk about it? All right. So I like to start with, on this one, since I have to fill it in, I'm gonna start with the profit. I'm gonna start with kind of like the ending piece. It says my profit per acre of potatoes is 150 and profit for corn is $50 an acre. Okay, so if I think about this last column as the profit column, or row, excuse me. I've got my two numbers, 150 and 50. What do you think we should label these top guys so that the 150 and 50 fit down here? Corn and potatoes, good. I'm gonna label the first one potato since that's what that one says, so 150. And then corn was the second number given to us, so I'm gonna label that 50. It doesn't really matter what order you label them in, but remember also with profit and with cost, there's no number back here. So this is our max min equation. And when we are talking about profit, we want to do what with that? Maximize. We want the most profit. So we're going to do 150x plus 50y equals profit. Okay. Now, if we know that potato and corns are our category or our columns, we got to fill in the other rows. What do you think what's one of the things for one of my rows is? What's one of my labels for one of my rows, you think? Cost, we can do that. I'm going to specify and call it seed cost because we've been doing cost just by itself. Actually, I should do that in a different color. How much does it cost to buy seeds for potatoes? How much for potato seeds? $20 an acre, good. What about corn? $60 an acre, perfect. And then how much total money can I spend on seeds? 3,000, good. Can I spend more or can I spend less? Less. I do not want to spend more than that. So I actually, instead of having that greater than or equal to sign, we're gonna do less than or equal to this time because we cannot go more than 3,000. We can go to 3,000, we cannot go past it. All right, any ideas on what that last category will be? Yeah, we're gonna say acres. The acreage is kind of hard though, because it says the very first line, I think, says a farmer has a field of 70 acres in which he plants potatoes and corns. Corns, that was weird. Corn. Is there a reason, like, do we need more potato? Do we need more corn? Can it be equal? Like, is there anything specific we know about distributing it up? What'd you say? We don't know it yet. We don't know it yet. So we're going to just treat it as equal. We're just going to say, we'll call it X and Y. The reason I would say unequal, or we could actually even better, let's just go 1 and 1. Because we'll just say potatoes is X and corn is Y. I'm so sorry. We'll just call it 1 and 1. If it said he needs to plant twice as many potatoes, or he needs to plant twice or 3 times as much corn, we would represent that here, but we don't have that. It's just evenly going to be distributed. Then we'll say 70. Can he do more than 70 acres? No. No. So we're going to do another less than or equal to. Okay. Now, why don't you take a minute? Why don't you do your equations, do your graph, do your matrix if you want to check it that way, see what our maximum profit is, okay? So just like we did before, I would personally go straight to my equations, take my table, make my equations, and then graph them. Oh. Oh, you're good. I like this new desk. I think I do too. I'm gonna like when this desk is gone. All right, I'm gonna join you writing my equations. Oh, that was weird. And then don't forget the x is greater than or equal to 0 and y is greater than or equal to 0. I get to graph them next. Yeah, go for it. Oh, wait a second, guys. Coach Vogel's calling me. Hey. It's okay. You left the camera in the front of the physics room? Yeah, absolutely. That's it, just the camera bag? Okay, yep, I got it. Yep, thank you. Okay, bye. Help me remember the camera is in Coach Vogel's room in the front of the physics room. Tell me that before or when class ends, so I might forget. Sorry for interrupting your class, guys. Okay, so I've got my lines graphed, and now remember these were all less than, so we're gonna shade smaller than, we're gonna shade less than. And so I'm gonna shade my little purple line. It's right in here. Blue line. All right, cool. Okay, now the issue is here. We got to check the 3 points. So I see 70 and 0 is a point that is in both blue and purple. We got to check 0 and 50. It's both in blue and purple. And it looks like, I know my graph is not exactly perfect, but it looks like it's this point right here. We're going to count it as close to that line as possible. That is 10, 20, 30, 10, 20, 30, 40. So we're gonna do the point 30, 40. So we're gonna check all 3 of those points to see which is my best profit. So 0, 50, 30, 40, 70, 0. Okay. Now, what's tough about this is that the answer that we get is not going to be the answer you get on your matrix. And we can talk about that a little bit more tomorrow on how to kind of read this. But the reason that I give you guys the graph and the equations is because I want you to do all of it. We can plug this in for our matrix really quick to check to make sure that our matrix will spit out the point 30, 40, which it will. That is where they intersect. in this case, since it's a less than, it does make sense to plant more 70 acres of potatoes and 0 of corn, just because of the way that the cost and the profit work out, right? Now, if that was not an option, if they were like, you must plant both potatoes and corn, then the middle one would be the best option. But if all we have is that we have 70 acres and we can plant either, this 70-0 would be the best bet to do. Okay. I'll plug it into my calculator very quickly. I'm plugging essentially this into my matrix. Oh, come back. One 70 20 63,000. Oh no,
Hey, and it makes chicken.
I haven't gotten that all day.
Chick-fil-A.
Chick-fil-A. I am like very hungry right now, but just confirming, if you do get 30-40, so if you are not sure what this intersection point is, that might be a good use of your matrix to double check. Okay. I do not see you guys tomorrow, but I do want your 7-5 homework due on Monday. I see you on Monday. I would like that due. Okay, I'll pass back a bunch of papers tomorrow. I'll pass, or not tomorrow, when I see you next Monday. I'll pass your quizzes back on